Hello, everybody. So today is Tuesday. Yesterday was your test. I hope that went well. And we're going to bust through 3 learning targets on Unit 2. So 1 day per, which is good news. Continuity we might spend 2 days on. But for right now, this is the schedule. Friday will be a work day for you to keep up on your homework. LT 1 and 3, I'm absolutely confident we can do in 1 day. We'll have another quiz on Monday for learning targets 1 through 3. So learning target 1 is about maximums, minimums, and these intervals. So some quick definitions. This is pretty intuitive. An increase in interval. Basically, if you read the graph from left to right, when is it going up? That's the increasing interval. Notice I said when. So your answers are in x values. So what are the x values that will produce the rising part of the graph? That would be the increasing interval. And the decreasing interval are the x values that produce the decreasing part of the graph. And then a constant interval would be a flat horizontal part of the graph. We'll get through examples on all 3 of those coming up. This is worth thinking about. So an increase in interval, an interval is a set of x values, but that means for any 2 points there, for any 2 ordered pairs, an x comma y, x comma f of x, for all the comparing 2 x values, if the x values are increasing, then so are the y values. That will happen on an increasing interval. So for example, here are 2 ordered pairs. Look at the x values. From -10 to -8, the x values are increasing. And so are the y values from -9 to -1. So if that is true for all x values in an interval, then that interval is an increasing interval. And a decreasing interval is between any 2 points in this interval. If the x values are increasing, so -10 to -8, that's an increase in the x value. Look at the y values. The y values are decreasing. -9 way down to -55. So if that occurs, then that interval is decreasing. And when it says positive change in x and -10 to -8, you're increasing. Well, think about it graphically. If you're going from -10 to -8, you are looking at it from left to right. So just always look at the graphs from left to right. And then a constant, if you're again reading from left to right, or in this case, the x values are getting bigger from -10 to -8, and there's no change in the y value, then it's a constant interval. So this is one of those things where it's the easiest thing in the world to just draw something or put your finger on it and say, right there, that's an increase in interval right there. But you're going to lose points if you don't express it correctly. So let's practice. Here's the same graph, but without the arrows. There's an increasing interval right here, and also a smaller increasing interval right here. Reading from left to right, you would be increasing here and here. Well, the way to express it are the x values that produce those 2 sections. What are the x values that produce this section? It is -infinity all the way to this x value, which is -1.545. And then the other one is from this x value all the way to this x value. So -0.5 all the way to 1.295. So those are the 2 intervals, the 2 sets of x values that produce y values. Decreasing intervals, well, this section is decreasing, and so is this section right here. But I'm 100% confident you can see that, but can you express it mathematically? What are the x values that produce this section right here? All the x values from this x value to this x value. So from -1.545 to -0.5. So there's one interval, but then union, there's another one. This section, of course, is decreasing. So what are the x values that produce this section? Starting with the x value 1.295 and then continuing on to infinity. Constant. Where are the constant intervals? There are no constant intervals. Nothing on this function is constant. There may be points like this top of the hill right here. This top of the hill, you can argue that you're neither increasing nor are you decreasing, but it's not really an interval. That's just one single solitary point. So this function has no constant intervals. Unlike this one, here's another function, and of course there's a constant interval right here. If you're in this space right here, no matter what two x values you choose, the y values will show no difference. The y values are always 2. So let's just get that one out of the way. Constant. What is this constant interval? From what x value does it begin all the way to what other x value? So from -1 it begins, it looks like, all the way to +3. That's the constant interval for this. Decreasing. Well, it's decreasing obviously right here, but how do you express that? From what x value to what x value? Starting with the x value 3 all the way to infinity. And then it's increasing in this section. What are those x values? From -4 all the way to -1. Here's our lovely graph again. Maximums and minimums. So the maximum of a function is the greatest range value. And this one has a greatest range value right there, 4.994. That is the greatest range value. So that's the maximum of this function. There is no y value greater than 4.994. And that occurs when x is 1.295. Now, a relative maximum is the greatest y value in a particular area. So right here, there's another kind of like maximum of sorts. It isn't the maximum. Again, 4.994 is the maximum. This y value is 2.705, but this one, relative to the other y values beside it on either side, it is the greatest y value compared to its neighbors immediately left and immediately right. So that's called a relative maximum. And that the relative maximum is 2.705, and it occurs when x is -1.545. We have minimums and relative minimums too. A minimum is the least range value of the function. So look at this function. What's the smallest possible y value? Well, it goes down. There's supposed to be arrows here, but it goes down forever. It goes down to -infinity. So you couldn't even say -1,000,000 because it keeps on going down past that. So this function doesn't even have a minimum. It never bottoms out. No matter what y value you say, I can name one that's even smaller that's on this function. A relative minimum is a small y value, but compared to its neighbors. Is there a y value that's smaller than the other y values immediately to either side? Yes, right there. This y value 2, is a relative minimum because the y values to its left and right are all greater than 2. So it kind of bottoms out a little bit here. This is a relative minimum. And the relative minimum is 2. It occurs when x is -0.5.